For this video, let's determine the distance of point X to the foot of the perpendicular. As you have noticed, we have some scribbles here because this was already part of the process of determining the foot of the perpendicular. That was actually one of the videos in this playlist, so please try to review that. I purposely paste here the scribbles on our Cartesian plane together with the process of determining the foot. The foot was actually identified as this. Okay, this value here, but nevertheless we will no longer concern to that. Our concern is the distance of a point X to the foot. In our Cartesian plane, this was our foot here, this one, and this was our X. So we were able to identify that point F, or the foot, is again this value, but this time we are asked about the distance of that. Basically, in our high school years, you can use actually a distance formula from F to X, and you could get the distance. But if you are going to target the foot of the perpendicular, you can automatically solve for the distance, because in this given formula at the bottom, this is the formula for the foot. This portion of the formula, the inner product of the x minus p, or the vector from p to x, and the unit normal vector is actually a distance formula for the foot to the given x. So if you would like to, this is the formula. X and f, or f to x, is actually just the absolute value, since we're talking about distance, and inner product can be negative as well. So it's the absolute value of x minus p and the unit normal vector. So simply take the value. So you can actually look at here, okay, from this portion, this was this region, by the way, this region here, and then it reached here, and then here, and finally you will get a scalar value of this. The negative sign is actually just the sign here, so it will not be taken into consideration. So this is automatically the distance of your foot to the x, the given x value. You may try to verify that using the distance formula. At this point, we will no longer try that. So this one is actually identified as 28 over, that was square root of 74. And if you would like to rationalize that, square root of 74, square root of 74, will actually get a result of actually 28 square root of 74 over 74 with no radical expressions. And this can still be simplified further by getting the factor, which is actually 2, in this case factor of 2. So you will get here, so by factor of 2, this is actually 14, this is 37. So you will get here 14 square root of 74 over 37. Now, as to the determination of your normal unit vector, please try to review the video pertaining on the foot, because it's right there. And just for the purpose of this, since it's already a part of the formula, let's have this in this manner. Thank you very much for watching.